Welcome to qnawire.
Hello friends, here it is given the parallel link mechanism ABCD. You can see here A, B, C and D used to transport a component I between manufacturing process at stations E, F and G by picking. So these are the manufacturing station E, F and G. By picking it up at a station when angle to be 0 degree. This is the angle, so this must be 0, and depositing it at the next station when theta is 180 degree. It is given that member BC, so this is B and C, this always remains horizontal throughout its motion. The link AB and CD rotate at constant rate in a vertical plane so that velocity of V always be 2.2 feet. Calculate minimum value of static friction between the components and VC. If component is not slide on VC, why it is to be transferred. We have to find the value of theta in second part, for which sliding is impending. Let us start solving it, drawing free body diagram of the material. Its weight will act downward, normal reaction. Here it will be a friction and it will move. It having normal force in this direction. Normal acceleration is v square by r, or you may write rho. Taking this direction to be x-axis, so summation of force along this direction, you may write F to be equal to mv square by rho. In terms of weight, it can be written as weight of the material upon g rho cos theta. Taking the summation of force along this axis, it can be written as n minus weight to be minus weight upon g into velocity square by rho sine of theta. So from here, normal reaction we will get weight into 1 minus velocity v square upon g into rho sine of theta. So maximum value of friction is mu s into n. Normal reaction we can substitute here g into rho sine of theta. And for the components not to slide, F must be less than F max So weight upon g, velocity of v square by rho cos of theta to be less than mu s weight 1 minus so by solving the above equation we can write coefficient of friction should be greater than cos of theta upon g into rho divided by square of velocity at p point minus sine of theta. We have to calculate the value of theta. Which maximize the above expression. Thus, d upon d theta of cos of theta divided by g into rho upon square of velocity minus sine of theta must be 0. So you may write minus sine of theta into g rho upon square of velocity at p minus sine theta minus cos theta into minus cos of theta divided by g into rho square of velocity minus sine of theta square to be equal to 0. By solving the above equation, we will get sine of theta having the value for coefficient of friction to have minimum value. So we can find the angle theta. Velocity is given 2 feet per second square. G is 32.2. Radius is 10 by 12 feet. So it becomes 1.180,373. So angle theta will be 10.39 degree or 169.61 degree. So from above result we can summarize the answer. Coefficient of friction having minimum value 0.1834, angle 10.39 degree and maximum 169.6 degree. That's all for it.